Hello everyone. In this video, I will give you a quick overview about my latest article, which was about the best libraries that you can use for medical imaging with Python. So, the first one here called PyDecom. So this library PyDecom is used for DICOM images or DICOM files. So it can help you to load DICOM files, read them, like you can visualize them with, for example, pyplotlib. But before that, you need to load them using PyDecom. You can visualize all the information about the patient. You can visualize or you can extract the information about the image, the file, so the dimensions, all these things. You can extract them using this library PyDecom. So for example, this is one of the examples that you can do. So you can use the function dcmread to read your file, DICOM file. And for example, if you want to extract the name, so you just need to put ds.patient name. I just wanted to select this part because this ds means dataset. So this ds.patient name, it will return a big line with more information that you don't need. So for example, you can choose only from 0 to 5 to select only the patient name. The other information you won't need. And for example, if you want to extract the patient's birthday, so you can just put ds.patient's birthday, birth date, sorry. And if you, for example, you want to know the study date or the ID, for example, here you can do study ID and here study date to get the study date. And of course, there are more. So I just put these 5-6 examples just to show you. But if you check the documentation, for example, here you can find all the other tags that you need. So you can use either these tags or you can use these variables, which are patient name, patient birth date, patient study ID, etc., etc. And of course, if you want to extract the image from this DICOM file, then you can use ds.pixelArray. So this pixel array will return a NumPy array containing the image, or the image file, so the pixel values, and you can use them after. Okay, so for example, if you want to extract the pixel array from this from one specific DICOM slice and you want to visualize it, so you can do that using Pillow. You can install it just like pip install Pillow, and you import PIL. You import this image class from PIL library. PIL means the Pillow here. Okay. So for example, you do the same thing, like you read the DICOM file, then you extract the pixel array, and then you need to convert it into float, so that if you divide by 255, you will always get float values instead of having zeros and ones, so that you will have the different pixel values. Because if you directly divide by 255, you will just have values like zeros or ones. But if you keep it as float, so you will have this pixel variability. Okay, so you do it the same here. You just need to do the scaling, so that you divide by the maximum, so that you will get values between 0 and 1, and after that you multiply them by 255, and at the end, of course, you need to convert them into integers, so that you will have only integer values between 0 and 255. And after that, you can convert this array into an image using this function from array, from the class image, which we imported from Pillow library. And this is only one example. You can check. I have a whole example for this in my website and in my GitHub repository. Of course, you can find all these operations. And this is only an example to show you how you can use PyDecom, for example. And and after that, you can just show the image if you want, using the show function from image here, which is from Pillow. Or if you want to save this slice as a PNG or JPEG image, so you just need to put image.save, then the name of the file, then the extension PNG or JPEG or anything you want. Of course, you need to choose a extension that is supported by Pillow library. Okay, so now let's go to the next tool or next library, which is Nibabel. So this function, or this library Nibabel is for Nifty files especially. So it helps you to load the Nifty file, which means you can read it, and you can return the header, which contains all the information about the dimensions, pixel dim, voxel dimensions, all these things, the affine matrix, all these things, you can find them in the header. So you can directly extract it like this. Or if you, for example, you want to extract the 3D array containing the slices, because in DICOMs there is only one slice, but in Nifty's there are multiple slices. For this reason, here we have only 2D array, and here we have a 3D array containing multiple slices. So if you want to return that array, so you just need to use this function get fdata, which means get frame data. So this function will return a 3D NumPy array that you can use for anything you want. And if you want, for example, to return the affine matrices, so you can just like put the name of the file that you loaded here, so which is niftyfile.affine, and it will return the affine function, the affine matrix, sorry. And for example, if you want to create a new Nifty file, for example, if you are doing segmentation or something like that, and you want to create a Nifty file from your output, which is a NumPy array, so you can absolutely do that. You just need here, for example, to use the nib, which is from Nibabel here, .nifty1 and nifty1 image. Okay, and after that, you have some parameters to put here. The first one is the data, which is required. The second thing is the affine, which is also required, but here the header is not required. So if you don't want to put it, you don't need to put it. But here for the affine, for their examples, they just put like a matrix, I matrix of 2 by 2, but it doesn't work all the time, because sometimes when you create a Nifty file using this affine matrix, like only an I matrix, 0 to 2 by 2. So when you use these functions, when you will try to overlay your segmentation or your on your DICOMs, it won't work all the time. So you need to pay attention to this affine matrix. We'll speak about this in future videos, and I will show you how you can really create the exact affine matrix, so that when you overlay your segmentation or your DICOMs, you will not get any problem when doing this operation. And after that, here in this line, we just created the Nifty file. But if we want to export it, so you just need to use the save function from this from Nibabel. So Nibabel.save, I just forgot to add here Nibabel.save, and here you put the Nifty file, which is here new Nifty file, which is this one, and of course you need to put the name plus the extension. So if you put only .nii, it will be saved as Nifty only. If you add .gz, so it will be Nifty, a compressed Nifty here. And of course, you can add the path plus the name. And yeah, this is all. There are more things about this. You can check them here in this in the documentation here. There are a lot of things that you can find and play. It depends to your project and what you are looking for. But this is only an overview for this library. If you want to take more, then you can check the documentation here. So now let's go to the next library, which is DICOM2Nifty. So this library, DICOM2Nifty, is mostly used, as you see, even the name here saying DICOM2Nifty, means that you can use it only for converting the DICOM files or DICOM series into Nifties. So you can implement it only using one line of code, which is this one. Of course, you need to install it, like pip install DICOM2Nifty. And after that, you can just call DICOM2Nifty, then .DICOM series to Nifty, and you put the folder or the path to the DICOM series that you have. So here you should have multiple DICOMs representing one case, for example, and after that you put here the name of your file, which is a Nifty file. So for example, output name here, .nii if you want it only Nifty, or you can add .gz if you wanted a compressed Nifty. And now let's go to the next library, which is simple ITK. So this simple ITK, it contains a lot of operations. So you can use it to load like Nifty's DICOMs. You can use it to visualize the DICOMs and NIFTs. You can use it to create DICOMs and NIFTs. You can even use it to do the conversion from NIFTs into DICOMs, which is one of the most difficult operations here in medical imaging. I am talking when we are using Python, but this FileDice library here will make your life easier when doing this operations. So I couldn't take all the examples because it contains a lot of things, but I put here the link to the documentation where you can find everything you want. So here it depends to what you are looking for. So you need just to put your keywords here in research box and find what you are looking for. Because if we want to just talk about this library, we'll pass the whole day here and we will not complete all what it contains. For this reason, I am just mentioning the name, and after that you can, if you want specific thing, you can just go and dig deeper in this library. The same thing here for VTK. So VTK is also a very, very large library that is implemented in Python, C++, and JavaScript. That's what I think. Even I think in C# you can find this VTK. So this VTK, like, it contains a lot of things. So you can use it for segmentation, for visualization, for 3D visualization, for a lot of things. Even, for example, if you remember, in my last video I talked about 3D slicer for 3D visualization, 3D annotation. So even this, for example, 3D slicer, it is based on this library, and a lot of medical or 3D visualization software are based on this VTK library. So it is very, very large library. So the same thing, I couldn't talk about it, but if you want to learn more, you can just visit the website here in this link. For example, I took this just one video from their website. You can see here they use it even for these type of things like holographics, and you cannot imagine how many operations you can do with this library. So for this reason, if you are really looking for a specific thing, you can just go to the documentation and search for that specific thing. Because the same thing, if I want to speak about it, I will spend maybe 1 week talking about it. But if you just need a specific operation for your project, then you can just go to the documentation and search for that, for the lines of code to help you doing this. And of course, there are a lot of questions and a lot of forums in Google. So you will find all these, all your questions, all your answers actually in these forums. Okay. So now let's go to the next one, which is like NumPy STL. So this library as well, we spoke about it in previous videos. So it helps you to convert NumPy files, NumPy arrays into STL files. Actually, it is not built specifically for medical imaging, but it can be used because we like say 90% we use STL files in medical imaging. So if you really are looking for converting your NumPy arrays into STLs, so you can use this library. So here is the documentation, and I have already wrote a blog post about this. So if you are really interested about how to convert the NumPys into STL, so you can just check out this blog post where you will find the code, you will find everything you will need to do this conversion. And after that, let's speak a little bit about this. For example, there is this MedPy, which is for medical imaging. So it is based on simple ITK library, and you can find it doesn't contain a lot of operations, but it can help you to do the conversions for multiple formats of medical imaging. So you can see here, I just took this from their documentation, which you can find here. So I will keep the link as well. And you can see that it can handle all these types of files. So this is like a huge thing that you can use for medical imaging. So you can just check it if you are using one of these files. So you can just check this library and use the functions needed. Now let's go to MONAI, which is used mostly for the machine learning algorithms. So if you are doing classification, segmentation, or something like that, or only pre-processing 3D medical imaging, So I really recommend this library, which is called Monai. So it is an open source software. It's an open source library for medical imaging, especially. It can be used for something else. That's I think, for my knowledge. So I have already built a 5 hours free course in YouTube, so you can check it out and learn how you can like take your first steps with this library. And of course, if you have any questions about this course, you can just keep them in the comments, or you can contact me in my email. No problem, I will be always there. Then, for example, yeah, for now we just, because there are a lot of libraries, but for me, I think the most used are these. So when you are, for example, using DICOM files, you will need this. If you are trying to use the Nifty files, you can use this Nibabel. If you are trying to do conversion from DICOMs to Nifties, you can use this one. Same thing for simple ETK, and some you will find that some libraries contains like operation that you cannot find in another, and the same thing for these here. Only, for example, we have this Monai library, which is used only for like pre-processing and for training the deep learning or machine learning algorithms for image classification and image segmentation. So only the algorithm that you will find in this library you will not find in the others. This is the only thing that is specific to this library here, Monai. So I think this is all what I can say. So, and for future resources, for now we are working on a full course about medical imaging for segmentation and classification, which is really coming soon. We are working on it. So if you are really interested about this course, you can just join our waitlist here, and we will keep you updated for all the news about our course and all the dates. And yeah, and I hope that this video was helpful for you. If you have any questions about these libraries, so please don't hesitate and leave a comment or send me a message in WhatsApp or on email me. I have no problem with that. I will try to answer you as soon as possible. And yeah, I see you in the next video. Bye bye.